Hello guys, in this video we are going to solve problems based on initial value theorem and final value theorem of Z transform. So let us see the question first. Find the initial value x of 0 and the final value x of infinity for the following Z domain signal. So we need to find the initial value x of 0 as well as x of infinite. So the given problem is x of z is equal to 1 by 1 minus z power minus 2. Negative power is there. Okay. So first of all, we'll try to understand what is x of 0. So if you might have studied the initial value theorem and final value theorem proof, right? So in that we have to just see the result. So if x of n is a signal, if I want to find the z transform, it will be x of z. The difference, you see, this is small x, this is capital X. Okay, so x of n z transform will be x of z. So when I apply limit n tends to 0, since it is initial, first I am talking about initial value theorem. Okay, so limit n tends to 0, I am applying limit to this function x of n, then what will be this? So it is nothing but x of 0, right? N tends to 0, limit n tends to 0, x of n. So putting n value as what? 0. So x of 0 it will be. So what will be the value of this? So it will be limit z tends to infinity x of z. So this is the initial value theorem. So x of 0, this is nothing but the initial value. So this, the whole thing is the result of initial value theorem. Now going further, let us see the final value theorem. Again, if x of n z transform is x of z, then if I apply the limit, okay, so this time I have to apply to infinity, n tends to infinity, x of n, to this I am applying, so that will be equal to what? X of infinity. Okay, so which will be equal to limit z tends to 1, z minus 1 into x of z. So this is nothing but the final value theorem. Okay, try to understand here. Here this was x of 0 initial value theorem, which is equal to limit z tends to infinity x of z. X of z will be given in the question. See here, the function will be given in the format of x of z. We need to apply limit and find out the answer of x of 0. Here also same thing, in final value theorem, x of infinity or x of infinite, which is equal to limit z tends to, it is 1 here, z minus 1 into x of z. Okay, so this thing you have to apply in order to find x of infinite, that is nothing but the final value. So let us see the problem now. Now let us look into the question. So here, as I said, as we discussed about the initial value and final value, so in question the x of z value will be given. So that is over here. Now in order to find, first we'll find out x of 0, which is nothing but the initial value. How to find that? We have to just put this thing, that is x of 0 should be the limit z tends to infinity x of z. So x of z is given, you have to just put limit for that. So which is equal to limit z tends to infinite, x of z value is what? So I'll write first x of z. Okay, so which is equal to limit, it's the same thing. Okay, lim and lt is the same thing, limit z tends to infinite. So x of z value is given, that is 1 by 1 minus z power minus 2. Or one more thing I should tell you, that always remember, when you are finding out the initial value, this z should be in the form of negative power. That means it should be z power minus 1, z power minus 2, like that. Or you can say, in other words, it should be in the form of 1 by z, 1 by z power 2, 1 by z power 3, like that form. Okay, since we are putting here z tends to infinite, that's why. Okay, so in initial value, you have to remember it should be in the form of negative powers. So when I put here, so I'll just simplify this. Limit z tends to infinite, this thing is not there. So 1 by 1 minus 1 by z power 2. I can write it in this form also, okay, for better understanding. Now here I'll substitute what? Z tends to infinite. So I'll put the limits here. So this will be 1 by 1 minus 1 by infinite. Correct? Infinite square you can put. It's the same thing, infinite only. So it will be 1 by 1 by infinite square will be what? 0 itself. So 1 minus 0, that is equal to 1 by 1, which is equal to 1. So this value is 1. So the initial value x of 0 is for this function is 1. Now we'll find out the final value, that is x of infinite. Okay, so this we need to find out. How to find out this? It's the same thing. Formula will be changed. Limit z tends to 1, z minus 1 into x of z. Okay, so this is given in the question. We have to just substitute over here in order to get x of infinite. So x of infinite will be equal to, now one more thing, as I said in initial value, it should be, the function should be in the form of z. That means it should be in the form of negative powers. Okay, so z power minus 1, like that. But here in final value, it should be in the form of positive powers, like z power 2, z power 3, like that. So we have to bring this into the positive power. Okay, so for that, so let us first write this one. Z tends to 1, z minus 1 into, z minus 1 is there. Okay, don't forget that. Here the z is tends to what? 1. There it was infinite. Here x of z will be 1 by 1 minus z power minus 2. So in order to bring it in positive power, so I can just write this as what? So limit, sorry, again this thing, z tends to 1, z minus 1 into 1 by 1 minus 1 by z power 2. It's the same thing. Okay, z power minus 2, I can write it as 1 by z power 2. So I have to just simplify this. Taking LCM, what will happen? 1 by z square minus 1 by z square. So this z square will go up, correct? So this will become z square by z square minus 1. Okay, so this will be the final function. So now the z powers, you can see, observe here, it is in positive, correct? Z power 2, z power 2. So now I have to just substitute over here. Okay, if you want, you can write all the steps. So here I will just write it. So this will be x of infinite will be equal to limit z tends to 1, z minus 1 into z square by z square minus 1. Okay, this thing only. Now here, observe here carefully, z square minus 1, I can write it as what? This is a square minus b square, a plus b into a minus b. So this I can write it as limit. Still now I am just simplifying this equation. Okay, so z minus 1 into z square by z plus 1 into z minus 1. Okay, like this I can simplify. So that I can just cancel these two terms, correct? So what is the remaining? Z square by z plus 1. Now I will directly put the value of z, that is equal to 1. Limit. Okay, I will put the value of limit into this function. So the final value z, you have to put it here 1. So 1 square by 1 plus 1, that is equal to 1 by 1 plus 1 is what? 2. So the final value x of infinite, that is the final value of this function, okay, x of z, is given by 1 by 2. So initial value was 1, here it is 1 by 2. So you need to remember all the steps.